Hi guys, today I have a video for you to talk about the exponential model, and the goal of this video is to help you identify nonlinear data and the model that would best represent it, how to write an equation for that model, and maybe some calculator tips. Alright, so let's get started. So first thing I'm going to do is I'm going to show you a list of data. I want you to pause the video and enter this into list 1 and list 2. So go ahead and do that. All right, so now that you're back, let's look at how this data is growing. So if you look at the x's, x goes from 10 to 16. So it looks like to get to the next number, I'm adding 1 each time. So by adding 1 each time, I'm growing in a linear fashion. I'm growing by a factor of +1. But look at the y's. I'm not adding a number to get to the next number. In fact, it's growing really fast. It's growing from 10 all the way to 800 in the span that it took 6 numbers over here. So we can see that this is probably not growing linearly. And so what you're going to do to check is you're going to do 21.8 divided by 10. And when you do that, you get 2.09. That means to get from that number to that number, you multiplied by 2.09. So to save time, I did the rest. So let me write those down really quick. And for practice, you should probably do these too. Oops. And okay, so it looks like it's growing by a factor of about 2.1, which means every time we go to the next set of numbers, the number before it was multiplied by 2.01. If you round that, that's about 2.01. So these numbers are not growing linearly, but they are growing exponentially, okay? So I'm starting to think that this data is nonlinear, but if I really wanted to verify it, I can look at the residual plots. So here are two pictures. This is a picture of a residual plot for x comma y. So what I did is I put x in list 1, y in list 2. Then I went to stat, calc, 8, list 1, and list 2, and I calculated the least squares regression line. Then in list 3, I went to second, stat, residual, and I plugged that into list 3. Then I graphed it by going to second, y equals, picking the scatter plot, and then choosing list 1 and list 3. Then I did zoom 9, and that's what that picture looks like. So if you need practice, maybe pause the video, try those instructions yourself, and see if you can get that picture. Now we can see that in this picture, we have ourselves a pattern. And we don't want patterns. So a pattern suggests that x comma y is nonlinear. All right, so we cannot use a least squares regression line to model the data x comma y. So what I did over here is I did the same thing, but now I tried x comma log y. So I put x in list 1, and then I went to list 3, and I typed in the log of y, but y is in list 2. So really I did the log of list 2, and I'll show you how to do that in just a second. Then I did stat, calc, 8, but now I'm going to do it for my new variables, list 1 and list 3, x and log y. And then I did in list 4, second, stat, residual. And I turned on my scatter plot, second, y equals, chose the scatter plot. This time I'm going to do it for list 1 and list 4, and zoom 9. And when I did that, I got this picture. Definitely a lot different than this one. I don't see a pattern anymore. So we have no pattern. No pattern is good, because it means that they're not systematically deviating from the line. So x log y is linear. And we'll practice this on the next slide, so don't feel like I went way too fast. We're going to do one more time. So I just wanted to show this to you to just really reinforce from the common ratios and from the pictures that X and Y was not linear. This is probably going to work for our data. Okay? So like I said in the previous slide, you're going to want to find x log y to write that least squares regression line, because x and y isn't going to write a good line. It's not a good model because we know that this is not going to be a line. So to do that, you want to find the log of y. So what you can do is you can just push the log of 10.4 and just do each one of these one by one. Or you can do them all in your list all at once. To do that, you're going to go to Stat, Edit, move your cursor over to the top of L3, and then you're going to do the log of list 2. So this is x, this is y, so now we're creating the log y. So here's x, here's log y. So you're going to want to write those down, make sure that yours match mine. And to save time, I've already written them down for us. Okay, so now we have this data, and we have an x and a log y, and we just said that it was this data, x comma log y will create a line. And so we know how to write equations of lines. We're really good at those. So to write an equation of a line, you need a slope and a y-intercept. And so unless the calculator, unless the quiz or test or question, whatever, asks for it, you can use the calculator to solve for that. If it does ask for you to do it by hand, go back and watch my scatter plot video where I show you step by step how to solve for slope and intercept. So in this video, I'm just going to use the calculator shortcut. So to do that, we're going to go to Stat, Calc, 8, and we want to do the linear regression, but the calculator wants to know of what. So you have to tell it of x log y. My x was located in list 1, and my log y was located in list 3. And some of you guys have the newer calculators where it just prompts you, where's x, where's y. So just go ahead and plug those in, go to paste, and then it'll paste it to the home screen. And when you do that, you should get intercept of negative 2.2 and a slope of 0.322. Once you do that, we're ready to write the equation of this line. So this was the slope that the intercept that the calculator gave us. This is the slope. So now I'm going to take those two values and I'm going to plug them into my least squares regression line. So I'm going to have log y hat equals negative 2.2058 plus 0.3222x. Now this is a log and it's base 10. So base means it's going to be the base of that exponential function. So we're going to do 10. So, and then this part is the exponent. So that's going to go right here. And the answer to this equation is this number right here, or this value right here, which is y hat, our predicted y. So now we just have to use some algebra to simplify this. So I can separate, if I have 10 to this exponent where it's adding, we can separate them by multiplying them by the same base. So as long as they have the same base, you can separate them with multiplication. Okay, and this is a number, and this is almost a number. We have, if you have an exponent and then two numbers multiplied, you can take one of those and put them on the outside, so I'm going to do that. And then I'm going to use my calculator to solve those. And so that's 0.0062 and 2.0999 to the x power. And this problem doesn't have context, otherwise I would have written words right there. So day and night or whatever. So, but we'll just leave it x and y since this problem doesn't have context. So what is this equation solving? This equation is called the exponential model. And exponential model is always going to be written in the form of a b to the x. And what this equation is doing is it's modeling your original data. It's modeling your original nonlinear data. We know this is nonlinear because we have an exponent here. And so this equation here, if we did it correctly, we'll go through those original points x and y. So let me show you, let's check if we did it right. So let's go ahead and turn on our original scatter plot. So second y equals, we're going to go to number 1, and you're going to pick scatter plot and list 1 and list 2. So that'll get us our original data. And just like we suspected in the very beginning of this problem, this is nonlinear. So now let's check if our equation really goes through those points. So you're going to go ahead and just push y equals and type in your equation, 0.0062 times 2.0999 to the x power, zoom 9, and it looks like it's working. That's always a good feeling when your line goes through most of your dots, because it means that you wrote a really good line. So I feel really good about this. And then the other thing this equation can do is this equation can also make predictions. So if I wanted to make different predictions, just like for the scatter plot, I can plug numbers in for x to predict y. So hopefully that helps explain some, helps you figure out some of this exponential stuff. I know it's a little bit tough. Hopefully this video helps. If you guys need any extra help, you can come to intervention or any of the study time